Hi, everybody. It's Professor Mitchell. Continuing with Chapter 5 on decimals. Today we are talking about solving equations containing decimals. And that is the only objective in this section. So just to review the steps for solving equations. First step, if fractions are present, they encourage you to multiply both sides of the equation by the LCD in order to clear all the fractions. Step 2, if parentheses are present, use the distributive property to knock down the parentheses. In class, I often combine these two steps, 2 and 3, into simplify the left side, simplify the right side. So if you have any like terms on the left side, put them together. If you have any terms on the right side, put them together. All right, and then this step is what we called in class, put apples with apples and put oranges with oranges. So if you have x's on both sides of the equation, use the addition property of equality to get all of the x's on the same side. And the same thing for the constant terms, get the constant terms on the other side. So at this point, you would have something like 2x equals 12 or 1/2 x equals 8, just a single x term on one side and a single constant term on the other side. So then the only thing left to do really is to divide both sides by the coefficient of x. Now we say divide both sides when the coefficient of x happens to be a fraction. We usually talked about multiplying both sides by the reciprocal. That's the same thing as dividing the fraction. And then step 6, you're always encouraged to check your answer in the original equation. So you don't have to cross your fingers and hope you're right. You can actually check to make sure that you're right. Okay, so for the first example, we have z plus 9/10 equals 1 3/10. So I like to talk about simpler, happier times. In simpler, happier times, this might have said z plus 9 equals 13. So you just look at what's being done to z and you undo that. In this case, what's being done to z is 9/10 is being added. We need to do the opposite of that, so we need to subtract 9/10 on both sides. So on the left side, the 9/10 will cancel. Let me just bring my pen up here. These two will cancel, and that will leave you with 1 3/10 minus 9/10 on the right side. 1 3/10 minus 9/10 is 4/10. So in this section, I'm not going to spend really any time explaining the arithmetic with the decimals. I would encourage you to keep a calculator handy. Okay. And then at this point, you've already demonstrated to me that you know how to do the decimal arithmetic, add, subtract, multiply, divide by hand. You've demonstrated to me that you know how to do that. So at this point, feel free to use a calculator to do this kind of problem. All right, so the check for this problem, you would take the original equation, z plus 9/10 equals 1 3/10. You would substitute 4/10 for z and just verify that that's correct. All right, let me get rid of my scribble here. Next example, 17/100 x equals negative 34/100. So in this case, x is being multiplied by a number. The way to undo multiply is with divide. So we are going to divide both sides of this equation by 17/100. All right, and once again, let's see. This and this are going to cancel out. That was the whole point. So x is going to equal negative 34 hundredths divided by 17 hundredths, which is -2. All right, and you can check that one on your own. All right, if you're feeling confident, you might want to give this one a try. This one is just a little more complicated. Notice we have an orange over here, we have an orange there, and we have an apple here. All right. Remember that in class we used to call variable terms apples, and we called constant terms oranges. Okay. So think through your list of steps. Step 1 is if you have fractions, get rid of the fractions. We don't have any fractions. Steps 2 and 3 combined is simplify the left side. Well, 2 9/10 is as simplified as it gets. And then because these two terms are not like terms, I can't simplify that either. All right. So I go right to the part where I put the apples with the apples and put the oranges with the oranges. Since I have a constant term on this side and also on this side, I am going to subtract 1 7/10 on both sides. And of course, the reason I'm doing that is so that this and this will cancel. All right, and I'll have oranges on this side, and I'll just have an apple on this side. So now 2 9/10 minus 1 7/10 is 1 2/10. These two dropped out. So now this looks a lot like the equation that they gave us in the last example. X is being multiplied by 3/10. The way to undo that is to divide by 3/10. 1 2/10 divided by 3/10 is 4. One of my favorite sayings when I'm talking to classes is don't be a hero. All right, so again, keep your calculator handy, and instead of putting yourself through, 1 2/10 divided by 3/10, hopefully you know how to do that without a calculator. But, that was an earlier part of the chapter, so that part is done and over with. I would rather see you do it correctly with a calculator than get it wrong because you messed up the arithmetic. All right. Let's see what's next. Okay. Hang on just a second. Yeah, I had something on my screen that was blocking that. 8x plus 4 2/10 equals 10x plus 11 6/10. This is another one that you could try if you're feeling frisky. So it's kind of like the last example. Here's an apple, there's an orange. There's an apple, there's an orange. All right, so I go through my list of steps. Fractions, I don't have any fractions. Simplify the left side, already in simplest form. Simplify the right side, already in simplest form. So it looks like, once again, we're starting out with put the apples with the apples, put the oranges with the oranges. All right, so the first thing they did was they subtracted 4 2/10 from both sides. This is one option, all right? It's not the only way to do it. It looks like what they're working on doing is putting all the constant terms on the right side and putting the x terms on the left side, but you don't have to do it that way. Okay. All right, so the reason for subtracting 4 2/10 from both sides is that that's going to get rid of the constant term on the left side. And that is going to leave us with 8x equals 10x plus 7 4/10. So now my only constant term is on the right side. I need to put my variable terms on the left side. So I'm going to subtract 10x on both sides. And of course, that is going to, that is going to get rid of this. And it's going to leave us with negative 2x equals 7 4/10. So the way to get rid of that negative 2, because it's being multiplied, is to divide it, right? Divide by negative 2, you're left with x equals negative 3 7/10. And again, it would be a really good idea to check that one. All right, next example. 6 3/10 minus 5x equals 3 times the sum of x and 2 9/10. So the only difference with this one is they've thrown in a set of parentheses. All right, always, always, always feel free to pause the video and try one of these. Don't always have to wait for me. All right, so fractions, we don't have any fractions, but we do have parentheses. And again, I put that under simplify. Okay, so let's distribute this 3. Let's see. Oops. Okay, so I'm going to take that 3 and I'm going to multiply it by x, and then I'm going to do 3 times 2 9/10. So that is going to give me 6 3/10 minus 5x equals 3x plus 8 7/10. All right, so let's see which way they went with this. You always have 2 options. When you're solving this kind of equation, you can put the x's on the left side or on the right side. Okay, and then of course the constant terms have to go on the opposite side. So it looks like in this case, they are sticking with put the x on the left side. And that's how some people do it. They just always, always, always put the x's on the left side. That's not always the quickest way to do it. In this problem, it doesn't make any difference. Okay, so they're trying to get rid of this 6 3/10 by subtracting it on both sides. Okay, so that's going to get rid of this, and it's going to leave me with negative 5x equals 3x plus 2 4/10. So now I need to put the x's on the left side. So the next thing we're going to do is subtract 3x on both sides. Okay, and that is going to get rid of this. All right, so I have negative 8x equals 2 4/10. We're going to divide both sides by negative 8, and that's going to leave us with x equals negative 3/10. And again, please, do try to get in the habit of checking all of these. Check them in the original equation, all right? And the reason for that is, I could have made a mistake going from this step to this step. And so if I check it in any later version of the equation, if my mistake happened before that, it's not going to catch the mistake. All right. 2/10 y plus 2 6/10 equals 4. This one actually seems a little simpler than maybe the last couple. All right, I know what I would do with this one. Oh, okay. Somehow I didn't notice this when I looked this over earlier. This is not something that you have to do, all right? If what we were doing in the earlier problems was working for you, stick with it. This is completely optional. Some people like this. So when you have a bunch of decimals in your equation, this is only for equations, and let's say those decimals are all just 1 decimal place, then you can actually get rid of the decimals by multiplying both sides of the equation by 10. Some people like that because it makes the equation look a little nicer. So what's going to happen if you do that is this 10 is going to be distributed. I've taught beginning algebra many, many times. And I am honestly torn between clearing out the decimals or not. I think lately I've kind of decided to go with don't clear out the decimals because some students make mistakes with the algebra doing it this way. But again, if it works for you, please feel free to do it. Okay. There we go. All right. So 10 times 2/10 is 2. Remember, just move the decimal over by 1. 10 times 2 6/10 is 26. And then 10 times 4 is 40. So this looks like the kind of equation we had back in chapter 3. That's why some people like this. It makes it look a little prettier. So now we are going to subtract 26 on both sides. That's going to give me 2y equals 14. Divide both sides by 2. You get y equals 7. And that's the end of section 5.6.